Yeah, thank you very much, Terry, for this excellent talk that basically emphasizes the importance of correctly representing identification of entities through these reference schemes. I think that people underestimate the importance of this, and I always wonder why conceptual modeling notation, they basically none of them, basically I guess some exception with the ER notation, some variant of the ER notation you mentioned, the variant of Berndt-Heilheim. But basically no conceptual modeling notation really consider this as an important topic to have it natively in its language. So, I mean, an information system, this may be your brain, the information you have in your brain, or maybe an information that sits in a database, cannot be communicated to anybody else or becomes holistic if there is no way to talk about the object that this system is talking about, your brain is talking about. That's why we as humans have this deistic notion, what you were calling abstention, or they have this notion of proper names. Proper names are sort of conventions that we have in our cultures, and through our eyes we can communicate the identity of objects, and having this in I think it's a truly conceptual modeling concept, the notion of reference schemes. And really, ORM is the only system that has this stuff natively. And this is my provoking question in a sense. So is it fair to compare ORM? How you do reference schemes in ORM with respect to other systems that don't really have it? So basically you have to encode this using the constructs like in OWL. So you can do many things in OWL. It's a complex logic. But then of course what you get is something that doesn't really look like a reference schemes or an identification constraint. It's just a logical formula which sits there. Similarly, you do something like that in UML. And so do you think that basically your ideas on reference schemes are ideas that really do not really depend on the conceptual modeling language, but are just applicable to any conceptual modeling notation?
Well, different notations support, and provide different levels of support. I mean, for real world modeling, you want to be able to model any reference scheme used in the real world. So with ORM, you can do it. With the other approaches currently, there's no way of well, you can do a lot of it. Relational databases, you can do almost anything. But it's not all graphical. I mean, when you're trying to figure out things yourself, it's nice being able to visualize the structures. And when you're trying to validate a model with a domain expert, not all of these people are very technical. A lot of them will let you work with diagrams, and even though initially they say, oh, ORM is too rich, it's got too many symbols, but then as soon as they find they got a problem where they really need it, then they tend to come around and say, oh, and they like it. But for those who resist, I say, all right, let's just give you the verbalization. It's unambiguous verbalization, so it's a controlled natural language. And they can understand it, and one of the nice things you can do, although I didn't show it there with the normal tool, you can populate everything with instances. And if you want to check on some constraint, I can remember doing this. I mean, geez, I had one client once. He wasn't actually good at English. I mean, at least in a logical sense. I mean, people like ourselves, you know, trained in logic or at least good grammar, which nowadays seems to be a bit of a lost art in certain quarters. He didn't know the difference between at least one and at most one and exactly one. He didn't know the difference between them. I found it, I misunderstood him for quite a while. And And then I realised, by God, this guy just is not very careful with words. And then I realised the only way I could figure out what he really wanted to say was by using examples. So in ORM, you just populate everything, and especially use counterexamples. Use positive examples to reinforce what the constraint means, but you use counterexamples that violate the constraint to check whether it really is a constraint. And it was only when I populated with this guy in particular, when I gave him counterexamples to what he was saying, he realised, well, I don't really mean that at all. After that was one of my very first industrial consultancy jobs way back about 40, 50 years ago, whatever. But I learned from that the value of examples, and particularly counterexamples. So in interacting with clients after that, made great use of examples. And it breaks it all down for them. But visually, as a modeler, it really helps to be able to see it all graphically. So I don't know whether I've kind of digressed a bit, Enrico.
Well, I guess that to use other words which have been used in the knowledge presentation community since many years, and at the end of the 80s, it's not just a matter of having a graphical construct, the thing that you are talking about. It's really providing an evidence of an epistemological construct, which is important as a primitive construct in your representation language. So that's the difference between, I don't know, first order logic, where you can do everything, or second order logic, you can really do everything, whatever kind of representation you want. But you have to, the primitives are not really expressing the epistemology of your knowledge, or the epistemology of the construct that is needed to represent your knowledge. I guess what is important in your proposal is that this is not only because you have a graphical construct, but because you also have, you emphasize the fact that there is a need of this kind of constructs in any conceptual modeling notation, I guess. And I have another second question, then I go on with a question written by the audience. My second question is, again, about being fair with respect to the other notations, in the sense, UML, in my perception, I see a dualism between conceptual modeling notation. On the one hand, I have ORM and ER. On the other hand, I have UML and OWL. And why is that? Because I say that UML and OWL are object-oriented languages, in the sense that in the models, in the databases, in the information they want to represent, you have objects that by themselves are the instances of that themselves represent the instance you have in the real world. So you have the object identifier in your semantics. On the other hand, in ER and in ORM, the models, the legal databases, are relational databases that contain only values that don't have object identifiers. So in this sense, in UML or even in OWL, reference schemes are second-class citizens by necessity, because people don't really need. They identify things by having the object identifiers itself in the data. What do you think about that?
I agree, at least part way in what you're saying. I mean, UML used to be very much that way. So UML was really I would say, for modeling a computer program more than anything else. In fact, many of the aspects of UML are really down at the implementation level rather than being at the conceptual level. But I mean, as UML went through different versions, they eventually did add, that ID in braces that you could put next to an attribute or whatnot, indicating, hey, that's the primary identifier, and you could actually use, a real name or something. You could have a country class, and you can have a code with an ID after it or a name after it. So that's actually using the real ways. Now, however, I have seen, I even went to so-called masterclass on UML some years ago, where this guy was modelling some stuff, and it was just completely wrong. And where he stuffed it up is he was using object identifiers to identify everything, and they were not related in any way to proper names or whatever. They were just, may as well have invisible oids. It was just, had no relation to the way anybody would think about them. And he was so blatantly wrong, and it was so obvious. He didn't, and he was the teacher, right? He was the master. And bloody hell, you know, you've got to populate with real examples in the way reference schemes that people actually use in practice. Otherwise, you know, you can end up doing stupid things, which what he did. So, I mean, I don't know whether that answers your question, but I think UML has improved. I mean, it used to so many bad things. I mean, I was actually, when I was working for what company, I forget what, but I was actually on a UML committee for a while where we worked on improving UML. And one of the things I had them change, you know, they had used to have a little or you put in braces for exclusive or, and I said, "You gods!" I said, "No, don't use or for the OR for exclusive or." I said, "Or in English is ambiguous between inclusive and exclusive. I mean, in Latin you had well for inclusive and out for exclusive or. They built into their language the two ors, but in English you just have or. We didn't have like the Romans did." And I said, "Well, for goodness sake, call it XOR. If you mean exclusive, or call it anything XOR." And they actually agreed and they put it in. But UML has so much of it, really, when you look at it, they're really talking about the blasted program code rather than the actual, you know, real world. It doesn't have to be done that way. There are some good UML modelers out there. But it's just, I don't know, it's so easy to, I mean, of course I'm biased, you know, I live and breathe ORM, but it's just so natural and it's so expressive, and I can just communicate in control natural language to clients, and I can visualize anything I want to see. It just makes it so easy. Anyway.
Sure. Okay, thanks for the answer. Now, I recall everybody that in this very moment, Terry is in Australia and it's 1 a.m. in the morning. So we have to thank him about his effort.
1:23.
1:23, exactly. Okay, so let me go through the questions posed by the audience. Well, the first two are about the relationship between ORM and NEAM and CogNEAM and the very first data modeling languages. So the questions are about why did you need to create this new language? What was different? What led you to create a new language that was different from it? And how other descendants of NEAM, such as CogNEAM, is different from ORM?
Yeah. I guess he's really asking why did we change it from NIAM to ORM. The original NIAM I learnt, you know, under Eckhard Falkenberg and Shea Nyssen, but I ended up teaching stuff at the university as well. And as I looked into it, I actually made some substantial changes. For example, even the what they call cardinality or multiplicity in UML, the original NIAM had something similar, and I thought, well, that's no good. They had this notion of what these call total roles or mandatory roles, and optional, but their notion of the uniqueness, the way it was done was like multiplicity, and I said, "You God, it's not orthogonal." I wanted to have a set of primitives that were orthogonal. So if I put a mandatory role constraint on, that is completely orthogonal to putting a uniqueness constraint on, right? So I could add one, take one off, and they don't impact one another. So I changed the meaning. I changed the semantics of what the notation meant. And then I started making other changes. The original NIAM was circles they had for object types. So first I changed it to ellipses, and then later on I changed it to soft rectangles. But I mean, I added, well, if you look at the original PhD I did, which was then, I called it NIAM then because that's what it was called then, but at the start of that, I've indicated some of the changes and extensions I made. Since then, I made an enormous number of extensions and changes to the notation. I would have been happy to still call it NIAM, but the company I work for in the States said, no, they said, no, you got to change it to something else. So that's when I said, all right, we'll call it object role modeling after Eckhart's original PhD. But there are other fact-based modelling techniques out, which all adopt the fact-based approach of not using attributes, which is fundamental. You know, CogNIAM is what Shi and Ocean's group at P&A use, and there are other ones out there, and they're fundamentally correct, I think. I mean, the notion, an attribute to me, is that's a lower level implementation thing. If you want to treat it as an attribute, that's at the really true conceptual level. I think you've just got facts, you've just got relationships. And okay. Certainly for logic, if you want to do it in logic, of course, there's none of this attribute garbage.
Okay, more question is about the connection with industry. So can you elaborate on domains in industry in which conceptual modeling is perceived to play a fundamental role, such as space? We know that you have worked with the European Space Agency, finance, and is the emergence of numerical methods such as machine learning, deep learning, make conceptual modeling somehow obsolete?
Good Lord, no. No, I mean, ORM is a general purpose conceptual modeling method. By method, it means both a language and a procedure. So there's a modeling procedure wrapped up with it. And it's also a method of transforming, so mapping from a conceptual level down to other things. It doesn't matter what it is. You can have any domain of discourse, any universe of discourse at all, and you can model it in ORM. I mean, I'm talking about the information content. I'm not talking about process modeling. I'm talking about information modeling. So any kind of information can be is suitable. It doesn't matter. Medical, space. God, there's so many hundreds of different, things we've done in industry. It just works with a lot. So any conceptual modeling should work with anything, because it's called conceptual modeling, not because it's some fuzzy concept or something. It's because you use concepts that are natural for humans to think about the things in the world that they want to talk about.
Okay, now I have a question from Giancarlo about the alectic and deontic modalities.
Yeah.
So it says, in your example of everyone is born in a country, but we don't have to know which one, you are in a subtle way hinting for the difference between representing facts in the word and representing epistemic states of the system. In the past, you also wrote, well, okay,
no. Okay, hold on.
Go on.
That's talking about open and closed world semantics rather than modalities, alethic and deontic. So in ORM you can declare open world, closed world, or open world with negation. For example, if you have a unary, say a person smokes, you can make it closed worlds, in which case it'll map to a Boolean, a mandatory Boolean, true or false. If you make it open world, then it's typically true or null. But we also support open world with negation, so you can have true, false, or null. You got 3 choices. So that's all built into the norma tool and everything. I mean, but in ORM, and in fact, in real life, sometimes your knowledge is any one of those 3. But alethic dionic. So dionic is rules of what ought to be the case, whereas alethic is rules about what must be the case. So, for example, I worked in Utah for I had 7 years. I worked at Microsoft. I resigned from Microsoft after a number of years and moved to take a professorship in computer science in Utah. And Utah, the LDS Church, that's the Latter-day Saints, or some people call it the Mormon Church. Originally, in the LDS, you could have many wives, all right? But then they changed their rules and said, no, we'll agree. You got to be monogamy. You can have only one wife. Although there was some fundamental LDS that used to disobey that, but basically the mainstream Mormon Church now, you're only allowed to have one wife. So you can imagine having a rule, I don't know, man is married to woman or something like that, and you want to put a uniqueness constraint, make it 1-to-1. It'll be optional 1-to-1, so it's each man has only one wife, each wife has only one husband. And you might say, hey, look, actually, no, some people are violating, that. Some people in the fundamentalist LDS, some of them have got many wives, and we want to see if we can detect them. So you could change your constraint from alethic, that each person has at most one wife, each man has at most one wife. That's alethic, meaning it is necessary that, and in other words, for each state of the database, each person is recorded as having at most one wife. If you change that, enormous, just a little toggle, you can toggle it to alethic, the constraint, from alethic to dionic. And dionic, the verbalization will now say it ought to be the case that each person has at most one wife. And now, if by some chance you put in, hey, Fred's married to Sue and the same Fred's married to Mary, it goes into the database, it's not rejected. But the the dionic constraint that each man has at most one wife, that dionic constraint is violated. The update is accepted, but the constraint is violated. So, have an event condition action. The event is the update. The condition in this case is the dionic constraint. The action this time will not be reject the update, but the action will be send a message to the appropriate authority that we've had this violation. So, I mean, that's a alethic dionic.
Yep. Another question is about, I guess, visualization and handling of large schemas. So it says, well, there are schemas that contain more than 10,000 types. It says in the Boeing Research Center tower, there is this long corridor wall painting where you have to run from floor to floor to capture the connection in the schema. So how can you handle abstraction nowadays in ORM? Zoom in and zoom out. How can you handle consistency among constraints? I would know the answer, but that is to you.
Yeah, you're right that ORM diagrams tend to take up a bit more room because we don't have attributes. Everything's done with relationships. In fact, 3M used to they used to have some massive models there. They had these whiteboards around the whole room, and even the relational schemas used to fill up walls. All right, they'd have like 1,000 tables generated. The models were that big. So there are different levels of abstraction you can have. So we build in, for example, into the tool, you can, I don't want to delve too much, but there are lots of different abstraction mechanisms you can have. One of them lets you focus on an object type and then expand outwards from it. You can break things up into multiple pages for a start, so you don't just have one page for the schema, you have any number of them. I've actually written papers on this, all the different abstraction mechanisms. I know at the ESA they really like doing making hierarchies of things as well. I mean, yeah, they are big models, take up a lot of room. But there are various ways of hiding information and abstracting and seeing just the bits you want to at any point in time, that are fairly well known, I think. And yes. It really just a matter of, it's similar if you're doing a UML one that's got 1,000 classes in it and whatnot. You've still got a problem. It's just maybe a little bit more graphically, a little bit more enormous because we don't have attributes. But I mean, I've never found it, and even the people at 3M, and they were the biggest models I've seen, they were quite happy with it because they could get all the detail that they wanted, which was more important to them.
Okay, we have two questions now that are about the fact that you are born as a philosopher. So it says, well, your work and background spans from philosophy, logics, linguistics, computer science. And so basically people ask, can you tell us a bit about your personal trajectory and whether you believe that these recent developments in philosophy, like formal ontology and the works about the foundation of understanding the basic categories of reality are connected to, can be connected to your work?
Yeah, certainly logic and philosophy to me are probably just the most important things I've ever studied. And certainly if you can't formalize what you're doing, then it's, you know, I wouldn't even think about it. So it's critical that you're able to transform any modeling notation you've got into a set of logical formulae, so you have a complete understanding of the formal semantics. In terms of ontologies, there's a lot of similarities between conceptual modeling and ontological modeling. I mean, ontology, strictly speaking, is say what are the things that exist? Ontos, right? Logos, reason, discourse. Reason, discourse about things that exist. So it's very, very similar, really. But there are some differences, and indeed, you know, I pointed out some of them. I mean, the open world approach for, you know, things like OWL and whatnot, many other ontological approaches. It's I mean, sometimes you want open world, but it's nice to be able to control and say, what do I want? That's one of the things I like about ORM. You can just say, I want to make this open world, I want to make it closed world, I want to make it open world with negation. It just depends on the situation. I can do what I want. I find some of the restrictions in OWL to be rather annoying. and I pointed some of them out. But really, there's so much in common between conceptual modelling and ontological modelling. They're much more in common than different. So I mean, yeah, I mean, in terms of philosophy overall, I mean, I still like. I mean, look at theory of definite descriptions that Bertrand Russell did. Of all the many theories of definite descriptions that have come out since Russell, I think his is still as good as any of the others that they've put into replacing. But I mean, one of our textbooks when I did like masters in logic, but even the first year textbooks was Principia Mathematica, which I really liked. But I guess nowadays they might do things a bit differently.
Okay, so there is a last question about, I think this is possibly related with the notion of objectification we were talking about earlier. So are you ever thought to consider, did you ever consider other modeling problems, something like reference schemes for relations?
Sorry, were you talking about objectification of relationships there, or
this was my comment. So the real question is, did you think about reference schemes for relations?
No. Well, we don't. No, you have reference schemes for objects. That's it. You don't have reference schemes for relationships. If you want to objectify a relationship, that's a different thing. So I can say, I don't know, students enrolled in a course, and then I might want to say that enrolment occurred on this date. When I say that enrolment, I'm talking about an enrolment object, which is in one-to-one correspondence with the act of where the student enrolled. I mean, the proposition, the student enrolled in a course, that's a proposition. If I say the enrollment's an object, it's not a proposition. So I guess it's opening up to what does objectification or reification mean, and in ORM, objectification is always situational, not propositional. So we're talking about a situational state of affairs. Propositions are truth holders, true or false, right? Every proposition's either true or false, but not both. Whereas the truth makers are the events or the situations, you know, the truth makers are not the same as truth holders. And you can set them up in one-to-one correspondence, but they're certainly not identical.
Yeah, I guess there's a long philosophical discussion to be done here. I want to give the opportunity to Giancarlo to make a question, but not before I remind everybody that next week we're going to have the next seminar in the EROSS series with Peter Gardenfors on conceptual spaces, cognitive semantics, and robotics. So Giancarlo, go.
Okay, yes, thanks a lot, Terry, for a great talk. So my question was related. So ORM, in the way you develop it, is much more than just the language and the methodology, right? So you have these other complementary things that really help with the understanding of the models, verbalization, automatic population, but even the concrete syntax, it gives me the impression that there is some sort of work or foundation on visual pragmatics there for the choice of the concrete syntax. So I would like to ask you to elaborate a little bit on this, on the role of verbalization of population and on the concrete syntax of ORM.
Yeah, well, the set of primitives were chosen to be orthogonal. So that's one key principle. Then you can have obviously different symbols, graphical symbols for them, but at least they're all orthogonal. So mandatory role constraints, uniqueness constraints are separate and independent constraints, unlike multiplicity in ORM combines them, right? It's all wrapped up into the one thing. So yeah, the choice of primitives is important, but I must be getting really tired. I'm just trying to remember what else was in that question again.
No,
something.
The role of automatic population, the generation of population, and the connection between the visual syntax and actually between the models in the graphical form and the verbalization. I mean, the role all these things together play in enhancing, let's say, the comprehensibility, appropriateness of the models.
Oh, it's vitally important, particularly the verbalization. So in the Norma tool, everything is automatically verbalized, right? It's just, and it's in controlled natural language. So, I mean, when you're working with a domain expert, doesn't matter if they understand the graphical notation at all. And if you want to clarify anything, you just show them the verbalization. And then if you want to check on something, use the populations. Populations to illustrate the constraint, what it means, and then also use counterexamples in your populations to really clarify that. And I've again and again, I mean, I find myself, if you're working with a client, you end up spending a lot of time with very small populations of to check whether a constraint is really what they really want. I mean, if trivial example, in our solar system, each moon orbits at most one planet, right? So I might have moon orbits planet as a fact type, and I put a uniqueness constraint on the first row, so a moon orbits at most one planet, and I don't put one on the second row. And then I populate it, and I might put, oh look, Phobos orbits Mars, Deimos orbits Mars, Luna orbits Earth. You know, those are simple 3 rows, 3 facts, and you can immediately see, oh, I can have many moons orbiting the same planet. Yeah, you're right. I don't want to put a uniqueness constraint that a planet can have only one moon. Anyway, yeah, that's a trivial example, but every time I'm having trouble with a client with them understanding, I use the control verbalization, or even I can maybe even more natural myself. There are some of the things we, expect for Norma have still not been coded in, but there are nicer things you can do in terms of the automated verbalization than what we do at the moment. So sometimes I use these nicer verbalizations myself, but the examples I use so much, and then you get it right. You get it right at the conceptual level before you map to a database and or whatever it is you're going to map to. So you talk to the domain expert who really understands the business domain and sort it all out with them first. And then all the generation of the other artifacts like, SQL Server databases or whatever, that's all kind of, boring, trivial transformation stuff.
Thank you very much, Terry. Back to you, Enrico.
Yeah, thanks very much,
Yeah.
Giancarlo and Enrico. It's been a pleasure to present, and also thanks very much for, I've been watching the series as they've been going on, and really happy with it.
Thanks to you, and good night to you, and good afternoon to all the rest of the world.
Okay.
Cheers.
Thanks a lot.
Yes.
Cheers.
Bye-bye.
Bye.
Cheers.